Hi. In 1975, I made a decision to try to learn how to program a computer. Like a lot of you at COFES, I'm up there in years, I suppose, which is one of my themes today. Having made that decision to learn to program, I really didn't have to make any more decisions. There was one computer I could use that I had access to. It was shared by 4 high schools. So I had one computer to use. It only ran one programming language. There was only one way to edit programs for that computer. And there was also there weren't any external libraries to use or debuggers. There was no stack to design. Since that day in 1975 where I started, I've, in one way or another, kept programming all the way to today. And over those years, I've seen a lot of changes. Many times I learned new programming languages, or new operating systems, or new paradigms, like event-driven models and so forth. But recently, I've learned about what I consider to be modern computing platforms and technologies, and I think that change is by far the most profound, important change that's happened in my computing career, is the one we're in the middle of now. And you've heard from Kai and from Mike about some of these topics. And in the next few minutes, what I'd like to share together is to take a perspective view on this new world of programming tools, and in particular, understand that it's not just like learning a new language this time around. It's really a completely new culture of how programming is done. And the cultural changes will get you if you just try and think about it as mere technology. And so my comments today are informed by my background. As I said, I've been programming quite a long time. I've been in the CAD business over 30 years. I was at MIT as a researcher, at computer vision as a programmer, and most notably I worked at SolidWorks for a really long time. And today I'm founder and chairman of a new startup company called Belmont Technology. Now between SolidWorks and Belmont Technology though, I took a year off and I tried to give myself a kind of self-taught refresher degree in computer science. And so some of the remarks I'm going to make today are drawn from this very influential year in my life. I had been learning all along, but this year I spent through 2011 and 2012, I took this class from Berkeley, an online edX class in software engineering for software as a service applications. I want to prove to you I'd actually had some kind of credential in this field. I did pass the class. I won't say what my grade was, but I'd be happy to say in private, but I did pass. It's a whole new ball game out there. And you sort of know this. Some of these topics will be familiar to you, but I hope that everyone can take away a little something new. By the way, this kind of talk is particularly suited for COFES. If we were at Google, I don't think this would be a useful talk, because I think everyone at Google sort of knows these things. But let's face it, the CAD industry is an industry filled with old applications. It's an industry filled with old people. One of the things I wish we'd see is more young people. I mean, we could take the children of the people in this room and build a pretty hip company, full of college students, and young people. Excuse me, Kai, I'm excluding you, because, there's a few of you younger people in the room here. But, so this kind of talk, you'll have to give me feedback on whether it's relevant or whether you all know this stuff, and I was kind of the last to know. But anyway, the future computing, or today's computing platform, we all know it's about cloud. It's about applications that run on many different client devices, not just a desktop computer, but laptops and phones and tablets and video games. And I even saw a TV on the wall that seemed to be running some form of Android, so I guess we'll throw that in now too. It's about multi-core, as we just heard, network bandwidth. My gosh, Kai knows way more about bandwidth than I do, but it's certainly, when I look at my Comcast bandwidth at home, it's going way up. I'm talking about a different kind of wide area network bandwidth, massive memory. And again, it's not just new technologies, it's a new culture. And the new way I choose to describe the new culture, it's like we've gone from what I call the Singapore subway model to the jazz music model. Let me explain what I mean. In the old days of programming, when I sat down to start working on SolidWorks, we decided to work on Windows, and we got a Windows development kit. And I liken it to the subway system in Singapore. It's perfectly organized. You can get a neat map of what it is, okay? Everything's clean and runs on time. There's a nice support number to call. But it's run by a dictatorship. You basically get what Microsoft gives. I'm not trying to say anything bad about Microsoft. I'm just saying the structure of all the big companies, for that matter, SolidWorks, in a sense, was a dictatorship too. We give the customer what we give them, and we certainly wouldn't dream of giving them source code or inviting them into our thinking about new products. That wouldn't happen. Some bad things about that, but some good things. Decisions are few. If you were writing a Windows app, you got the box. There's some heads nodding. You know what I'm talking about, right? You got the box, it had the compiler, neat reference manuals. Today it's a different world. I call it the jazz music model. It's like you expect to see some guy and it says, hey man, I got a new language, man. Check it out. There's no reference manual, but here's the source code. Let's change it. And it's like this whole world that's built around this new view. I was looking for reference manuals and support, and instead I was getting, everything was changing all the time, and there's so many decisions. This book says it all. JavaScript, the missing manual. Yeah, I don't know if you saw that. The missing manual. Now, I don't know how many of you have worked in JavaScript at all? Okay, quite a few. I call it the world's most popular programming language today, right? It's in every web browser. Every web browser that you're running now, you can look around for the JavaScript console in the menu bar and start typing code. If you're getting bored, go right ahead, no problem. And it's built in everywhere, and yet there's no reference manual. It's easier to get source code for things than it is to get a reference manual. I couldn't find one. If you can find one, tell me where it is. I could not find it. We all know it's time to say goodbye to desktop apps and hello to cloud apps, right? I hope that no one's thinking of building new desktop apps. It's not a particularly promising story here. I can see our previous speakers weren't particularly talking about that. Cloud, there really isn't such a thing as a cloud app. I hear people around here say, oh, it's just like the old days where we do the computing remotely and we have a dumb terminal. Well, I don't know about you, but I don't think these client devices are dumb terminals. These things have GPUs, they have gigabytes of memory, they have multi-core processors. It's not like the old days. This is not a big computer with some dumb terminal. This is a symphony of asynchronous computing activity going on. The choice is not whether to go desktop or cloud. That's not the choice. The choice is, do we use just the desktop computer by itself to implement a solution, one way to do it, or the same desktop computer plus a high-speed link to Kai's cluster in the cloud? I'll take B. You know what I mean? I say use both the desktop and the cloud. I think that's a much smarter plan for building modern computing solutions. So really think distributed applications. Goodbye picking a programming language. Hello choosing a stack. People talk about what stack are you using? You're not just using a language and a toolkit. You've got to pick a database, and there's got to be a caching thing on top of the database. You've got to pick the OS. You've got to pick the hosting provider or figure out your own hardware stack and worry again about all these intricacies of how it works. You need monitoring tools. You need a framework. There's all these different decisions to make, and guess what? They're all changing. Every year, every month, every week, things are changing. There's new things coming out all the time, and you have to have a new attitude about learning computing tools. You don't just sit down and say, oh, I'm going to pick a new language for the next few years. You have to be continuously learning. I said one day, I said to my wife, I said, I have to learn how to learn again. I have to learn a different way to learn than I learned programming. When I went, this isn't like going from BASIC to Fortran or Fortran to C, or C to C++. Those things were about learning in a certain style. This new world's very different. It's a different, you have to reprogram the way that you learn things. And there's a staggering number of things to learn. This looks like an overwhelming list of random buzzword bingo pulled from some internet application story. But in fact, these are all things that I think anyone who's building a modern application would want to know about just about everything on this list. You might not use it all, but you'd at least consider it. You can look at this list yourself. I don't know if you're familiar with many of these things, but it's shocking to me the amount of things you need to learn. And this is just a subset. Again, these are things that anyone who builds modern computing apps would probably know what every one of these things are and probably have tried them out beyond the scope of this discussion. One of the things that surprised me, okay, I might be old-fashioned, but everything's a freaking text string now, Back in my day, binary, everything you had to compress and worry about bits and everything. Now it's like, oh, JSON. Mike mentioned JSON, Mike real earlier. That's just text string. You can just read it. It's just a text string. XML is just a text string. CSS, HTML. Everyone know that every time you go to a web page, the dialogue between your browser and the server is text? You can open up a telnet window and go to Yahoo. Again, if you're bored, try it right now. Go to yahoo.com or google.com and type get HTTP, and what comes back? Text. All web pages are text. WebGL and OpenGL, the shaders are written in text. You send the text code down to the GPU, it compiles it. That's really cool. Where have I been? I'm finding it really interesting. I don't know about you. If you all know that, great. I didn't know. I found it really cool. We all know it's time to say goodbye to thinking about single processors and hello to thinking about multi-core. Everyone knows that CPUs aren't getting any faster, right? Your shiny new MacBook has a CPU that isn't really any faster than your old MacBook, right? Because nobody knows how to make clock speeds higher. Well, maybe some of those IBM Genie guys do, but as far as I know, we're hitting the fundamental limit of chips right now. So CPUs aren't going to get faster. The only way we make systems faster is to engineer around multi-core. And that's at the local client device level in the GPU. It's at the CPU. It's certainly true in the cloud. We need smartly engineered concurrent systems. And again, Kai spoke about that, Mike spoke about that. It's not as simple as just saying, oh, we'll just rewrite this old code and make it parallel or something. That's another thing I hear in these halls. And it's like, you really have to think wisely. And everyone knows, even from the old days of programming, that premature decisions about what to optimize are always wrong. Always. And so you have to think very carefully. No one less than Ivan Sutherland himself, the guy who wrote Sketchpad at MIT, of Evans and Sutherland. Look him up on the internet. I did. He's working on concurrent computing now. There's a video on YouTube of him talking at Portland State University. Well, there's good news and bad news on bugs, because now we're using memory-managed languages. Anyone know what a memory-managed language is? It's a language where you don't have to do... It's kind of like, I heard someone say to me, it's like when you're on vacation on a cruise ship and you just throw the laundry on the floor, and then the next day you come back and someone straightened it all up. You don't have to worry about allocating... That wasn't my line, that was someone else's. You don't have to worry about allocating your memory and freeing it. And there's so many bugs that come from referencing a pointer to something that's been freed. That all goes away in a managed memory language. That's good news. And to quote an article I read from Google, it says, managed memory is a nice to have in a single-threaded environment, but it's kind of a must-have in a multi-threaded environment because those memory issues will kill you. So the good news is no more malloc and free, no more bad pointer bugs. The bad news is we have all these new kinds of bugs to worry about in multi-threaded code. And I'm not an expert, and I don't have time to give it, things like race conditions and deadlock and all those mutexes that someone was mentioning. Those get followed up pretty easily. There are people with new languages and new approaches, but these worries are the new version of the old days where we'd worry about, oh, can I free that memory, or is that pointer still good? That's going out. New thinking about concurrency. Goodbye hard disk. I don't even think you can buy a MacBook Pro today with a hard drive anymore, right? They're all SSDs. And I got to thinking about it, and I thought, wait a minute, maybe we're going to say goodbye to the SSD anyway. Hard drive has become like a tape drive used to be. Hard disk. If you talk to the cool kids on the West Coast, they don't think about having hard drives. That's old. But even the SSDs, even the whole idea of disk is changing because we have such massive memory and 64-bit operating systems. Recently, this is just like a couple weeks ago, I noticed a setting in a utility I have in the Mac that would allow me to turn off virtual memory. Turn off virtual memory? What? And I thought, how cool is that? Years ago, I'll get to this in a minute, years ago the computer was precious and we paged disk into precious memory. And now it's like, you can turn off, there are people on the internet who turn off the virtual memory on their Mac and run their system, and apparently runs a little faster because you have so much memory you don't need to page to the disk. And by the way, memory's gotten so cheap, what is it, $5 or $10 a gigabyte? We could drive out right now and go buy a terabyte of memory, okay, at Best Buy, or certain Best Buy, yeah, this is a store. and come home, and we wouldn't spend as much as the car cost. You know, the car driving would cost us more than a terabyte of memory. You know, this is a real change in what's going on. So we'll probably see situations where basically all the data we'd ever care to access could be kept in memory at one time, assuming that nothing ever crashes and goes away, and, you know, but it's an interesting thought. Goodbye worries about computer costs. You know, I grew up in an era where you had one expensive computer, and then you had this army of relatively underpaid people around it. Now it's exactly the opposite. Smart programmers cost a fortune. If in case anyone's out there hiring, ask me how I know that, okay? But the computers are cheap. You know, computers are cheaper than they ever were. And so each person, everyone in this room owns a bunch of computers. You're probably carrying a bunch right now. You probably have 8 or 12 cores each on average. You have your phone and your notebook and iPad and, you know, whatever. You used to design to preserve precious computing resources. Now I think you design and you say, let's just save programmer time. Who cares if we have to buy another 100 gigabytes of memory? In fact, who does really care? You know, that terabyte of memory will probably cost, quick math will tell me, it will probably cost no more than a month's salary for an engineer to buy a terabyte of memory. So, you know, maybe if you're deploying systems at the scale of Google, you worry about memory, but I worry more about how much time precious development engineers spend. Finally, security. Different views. Security used to mean antivirus and firewall or something. If you're building a modern app, security is a very different concept. And again, we don't have time to get into it here, but you're worried about, you know, constant attacks from organized crime networks and nation states. We didn't have to worry about that. We didn't worry when we were putting desktop software installed on a Windows computer. We didn't worry about nation states attacking us, okay? This is a big issue. It's a whole different culture of security. It's not as much totally a technical issue. It's a greater thinking about a security culture. So those are some of the things. You might title it, What I Learned on My Summer Vacation or My Year Off. But I found this interesting. If you're an old dog like me learning new tricks, these are some of the things that I think have to be on our minds as we all together try and move into a new generation of technology and computing platform and a new culture to deliver the solutions we need to build. So thank you. With that, I'll be happy to take questions. Mark.
Okay, I have 2 questions. Number 1, being an old programmer myself, I remember QA procedures. In the world that you're describing, what are going to be some of the best practices for quality assurance with everything in such a state of flux? And then my second question has to do with memory. I'm thinking of large-scale computations where data locality on memory addresses can be critical if you're doing things like CFD or even large visualization calcs. So when you were saying you could just buy more memory and get performance, is that really true?
Okay, I'll respond in order. So first about QA. Well, there's a whole new culture of QA, and it's about, you know, about quality engineering. You have a different culture about, in some companies, there are continuous deployment of software where there's no human between the programmer's code and the running website. I don't know if anyone has experience in those environments, which means you have a level of dependence on automation that I think is unprecedented. And you have to test, if you're building distributed systems with asynchronous activity, I think it presents new challenges to test. You need new techniques and new kinds of thinking.
Are those evolving?
Pardon?
Are they evolving?
Yes. And what you find is, like a lot of things in this world, there's no clear, great, definitive answer. Kai may have an answer. You want to take a shot at it?
I'll just grab the QA question because that's something I worked with a lot. So I'll tell you a story. Web search, Google used to try to find browser bugs. So basically, they try to figure out how browsers fail. And at some point, they have JavaScript, basically error tracker, that when the JavaScript code fails in some browser, it sends them back an error. It turns out when you have enough machines and enough browser combinations, I mean, we're talking about thousands of permutations of browsers and operating systems. There's no way, obviously, you can manually test that. But your automatic system is not even good enough because the automatic system fails in some corner cases. What you end up doing is you end up looking statistically at the traffic levels. And if it turns out that some permutation of Windows XP with some browser here, your traffic levels today, Tuesday or today, Thursday, are different than last Thursday for no reason you can rule out, then you send in a human QA person to test on that combination to see if there's actual bug. Like when you're talking about the volumes and scales of things, that's the thing you go into. Like human resources are still needed, but you have a lot of these automatic statistical systems to try to kind of wean out where the problem is, because there's so many needles in such a big haystack. There's no way human QA is going to be able to go through and find just all the cases. So it's just an example of this, what John alluded to with this like programmatic thinking. You're more for rolling back code as opposed to making sure the code is really working. Like you're really aggressive with rolling out. Whenever you find a problem, you roll back immediately, and then you figure out what went wrong, and then you try again. So,
yeah. And it happens anyway. And then the second part of your question about the memory. Thank you, Kai. The second part of the question about the memory, you're absolutely right. I wasn't trying to imply that every performance problem could be solved by just buying a ton of memory and throwing everything in memory. It can't be. I just think it's interesting to take a perspective view, and change your thinking a little about what's out there and what's possible. But it takes great engineering. There's no easy answers to these problems, and you heard, of course, earlier about some of that, and I could. We can talk offline a little more about it, but no, there is no easy answer there. Any couple more questions in the back there? Oh, it's Peter. Hey, Peter.
Yeah. So I wonder if you have any comments on how the workflows changed. So when you started, we sat in a seat. In fact, we priced our systems by the seat. Work came to us. We sort of sat in the design room and stuff like that. Now you could make the case that that CAD systems will be distributed as apps, that there'll be different scenarios of workflow. I'm wondering if you have any comments not on how the software is written, but the context in which it's used.
Oh, you mean the changes in workflow in product design companies?
Exactly.
Oh yeah, absolutely. I mean, to me, we've had a huge change in how organizations design. I felt, 20 years ago, we'd see companies that did, as one company, and maybe they outsourced manufacturing. So today, it's a spider web of players and actors. So we've basically there's more different entities involved in the process, distributed all over the world, and it changes all the time. So it used to be smaller number of entities, like maybe, again, one company doing design, one doing manufacturing, and that was the way you did it year after year after year. Today, it's the industrial design's done by a guy in the UK, and the tooling's done in China, but manufacturing's going to be in Brazil. Oh, but wait a minute, that was last week. And there's this changing, it's this dynamic virtual organization, right? Basically everything changing, lots of people, data getting passed around in all kinds of ways that nobody really thought about years ago. The single vendor CAD doctrine is clearly dead. The idea that you walk in, at last customer I walked into, I visited a company recently, and they got all kinds of systems hanging around. Yeah, those sort of standardized on system A or B, but they've got C, D, and E also. They've got different versions to deal with, and yeah, that would be the number one thing I would characterize in that way. Yeah.
John, you mentioned programmer costs. Just to get an idea, let's say programmer cost was $100,000 a year 5 years ago. What would be an average cost for a programmer?
Well,
and another second
question. Yeah.
It's not a question. I mean, just 3 or 4 weeks ago, Google paid one of their engineers, he's from IIT, $50 million retention bonus as a programmer. So I just wanted to get you an idea on what's a matrix like.
Oh, wow. I think costs are all over the board, but, you know, talking to people at Google, they say no one at Google makes less than $100,000 a year. I don't know if that's true or not. I'd look to the ex-Google guys in the room or guy, you know. It's just, you know, it's just a lot higher than it used to be. I mean, I can't, maybe, let me think about it. You can catch me offline. I'll be around till Saturday, and maybe I can give you some data, but rather than throw out a number, you know, we can sort of talk about it. But it's a lot higher than it used to be, and it's very surprising, particularly in the hot areas like California and Boston. All right, well, thank you.